The management of the energy grids is set to radically change in the coming decades. Energy supply and demand are becoming more flexible. Decentralized, local, small-scale and sustainable energy production is expected to increase. There will be a growing need for interaction and collaboration between market parties. Striving to achieve a sustainable energy supply requires us to become more intelligent in the way we deal with energy. Among other things, that means that our present electricity and gas networks must become smart networks, also known as smart grids. One of the main characteristics of a smart grid is the growing amount of information about consumption, production, and energy flows. Information concerning the performance of the grid can be viewed remotely, and operations in the network can be carried out remotely. This means that the smart grid can only function when there is good and reliable data communication. Telecommunication becomes a vital element of the primary process of energy distribution. Liander has taken an important first step in making our energy networks more intelligent by constructing a dedicated private telecom network. This telecom network consists of fiber optics to connect our critical high-voltage substations and wireless connectivity to communicate with decentralized smart grid elements and smart meters. The fiber optic network between the high-voltage substations ensures high performance and availability required by current applications as well as future, more demanding applications. For communication with all the other smart grid assets and smart meters, which are spread throughout the geographical service area of a grid operator, Liander has chosen wireless connectivity. There are various wired and wireless data communication techniques available which could enable communication throughout the grid. Liander's choice for a private wireless network is both a technical as well as a strategic one. Given the critical nature of the communication, even when power fails, an autonomous solution is required. Therefore, Liander has opted for a private wireless network that uses CDMA 450 technology. Such a private wireless network offers autonomy and maximum control over, and optimal management of the communication infrastructure required for the various smart grid and smart metering applications. CDMA in the 450 MHz band offers good reception and optimal coverage of Liander assets. For example, deep indoor reception for our smart meters. A private network also offers increased control over the safety, reliability and cost of the network. Liander is the owner of the key elements of this private network, such as the spectrum license, the masts and the transmitting equipment. Liander therefore has full control over the network and the relevant strategic, tactical and operational decisions. Guaranteeing long-term continuity and safety of communications was another reason for opting for a private wireless solution. Smart grid and smart meter applications require long-term availability of communication. A 15-year lifetime is common for utility assets. On top of this, utility assets have to be able to communicate at any given moment, even when there is a power failure in a large area. Commercial networks cannot offer this reliability. Extensive studies have shown that a closed, dedicated CDMA network is the most suitable solution to fulfill these requirements. The fact that the spectrum license for the 450 MHz band was available in the Netherlands offered the opportunity for across-the-board control of all the relevant elements of a wireless network. Liander will not become a telecom operator. Liander is a regional network company specialized in the construction and management of electricity and gas networks. Liander has no intention of becoming a telecom company. Telecom is a speciality in itself and best left to the specialists. Therefore, Liander has established partnerships with telecom experts and service providers, namely KPN for network operation and Entropia Digital for construction and maintenance of masts. A private wireless network could also be suitable for critical applications outside the domain of regional network companies. For example, remotely controlling and monitoring of locks and water levels by district water boards, motorway signalisation, and possibly even more. This way, Liander's private wireless network could form the basis for a private, safe and shielded communication network supporting the critical public infrastructure in the Netherlands.